Good morning, madam. My name is E. Charan. I am from Triple Department, Triple A section, and my roll number is 244G50201. And my today's topic is about procedure for root locus, and we can see root locus, how we'll construct the root locus, and how we'll apply. Root locus, we can know first of all what is the root locus. The root locus is a graphical representation is S domain and it's symmetrical about real axis because the open loop poles and zeros exist in the S domain having the values either as real or complex conjugative pairs. In this chapter, we can discuss how construct the root locus. And we construct the procedure for the construction of root locus. Follow these rules for constructing the a root locus. Rule number one, nothing but step number one. Locate the open loop poles and zeros in the spline. Root locus branch starts from open loop poles and terminate zeros. This is nothing but to terminate the zeros, and root locus branch starts from open loop of spline. And step number two, that is nothing but rule number two. Find the number of root locus branches. We can also in this step we can find the determine the root locus on is a real spline. And rule number three, identify and draw the real axis root locus branches. We simply called as step number three, determine the asynchronous of root locus branch and meeting point of asymptotos with the real axis. And we can explain in this rule number three, identify mainly draw the real axis of root locus on branch. And step number four is nothing but to find the breakaway uh, point in find the breakaway and break-in point. Breakaway and break-in point we can see what is the breakaway point and what is the break-in point. Breakaway point is nothing but is a location on the real axis where two or more root locus branches meet and then diverge. It typically when two real axis poles are zeros merge and then separate into complex conjugates. Yes, this is about the breakaway point and we can say if there is a root locus on real axis between the poles, then there is existence of breakaway point. We can call this is also called as a breakaway point. And the break-in point is nothing but the points where two root locus branches meet on the real axis and continue on this axis in k as k increase are known as break-in points. Break-in point we can also another definition for break-in point if there is a root locus on the axis between two zeros and there is existence of break-in point also we can call it break-in point. And this is the step number five. If there is a complex pole in determine the angle of departure from the complex. If there is a complex zero, then determine the angle of arrival at a complex zero. If this is the step number five, and step number six, we can find the point where the root locus may across the imaginary axis. We can find this step. We can this any point of root locus may cross the imaginary axis. And the last step, this is the last step for root locus. Take a series of test points on the board neighborhood of origin of the spline and adjust the test point stability angle criteria. Sketch the root locus by joining the test point by the smooth curve. We can take this series from the second for the last step. We can adjust the 2 points of neighborhood origin of spline. This is the explain and imaginary plane and root locus branch and not a root locus branch. We can see the formulas for finding the root locus and angle of asymptotos that is equals to 180 into 2q plus 1 divided by n minus 1. M is nothing but number of poles and M is nothing but number of zeros. on is plane. And centroid, we can find the centroid, that is sum of pole minus sum of zeros divided by n minus m. Angle of departure, that is equals to 180 minus sum of angle of vector to the complex pole from other poles plus sum of angle of vector to the complex pole from zeros. And this is the, we can find this formula, we can find the angle of departure. And we can say angle of arrival, the is equals to 180 minus sum of angle of vector of the complex zeros from other zeros plus sum of angle of vector to the complex zeros from poles. And we can find this formula. By using this formula we can find the angle of arrival. And this is all about the procedure for constructing the root locus, and we can see steps for construction for root locus and also the formulas for constructing root locus. Thank you, madam.